Okay, so today we're going to learn about compound OR inequalities. Okay, my learning target is that I can solve and graph compound inequalities involving OR. Okay, so the first thing that we're going to do is learn how to graph these. Now remember, I talked about yesterday how AND inequalities, you have more than one condition on your inequality. Anytime you see more than one inequality sign, that means you have more than one condition affecting it. And inequalities have two or more conditions, but all of them have to be satisfied for your equation to be, or for your inequality to be true. But with ORs, it'll have multiple conditions and only one of them has to be satisfied for it to be a solution. Okay, so I'm going to have x greater than or equal to 5 and I have OR x is less than 3. So I'm going to plot both of those. I'm going to put my key points 0, 5, and 3. Okay, and I completely flub that up, right? Because 5 comes after 3. So I need 0, 3, and 5. Okay, so I need to have greater than or equal to over here. The line underneath implies that this is part of the solution. Less than, as an open circle, implies that 3 is not included in my solution. Now, do the 0 check. 0 greater than or equal to 5. Is 0 greater than or equal to 5? No, so I don't want to include that. My arrow is going to point away from 0. We don't want him. Okay? Now do the 0 check again for the second one. 0 is less than 3. That is true. We do want 0 in that one. So my arrow is going to point to the left of the number line. Okay? Now, I want you to pause the video and try B on your own. Okay, so what you should have done, marked your key points, 0, -2, and 5. Check the signs for which circle. So on the -2, it should be an open, you should have had an open circle because it's less than. On B, you should have had a closed circle. That's greater than or equal to. It's included in the solution. Then did your 0 check. 0 is greater than 5. Is that true? Nope. So it goes away from the 0. Do 0 is less than -2, also not true, so that's going to point away from 0 as well, and this is my final answer. They kind of look like the oars on boats, hence or sometimes. Not all the time, as we're going to see in these next couple of examples. Okay, so solving multi-step inequality with OR, I'm actually going to do example B. Now on your guys' paper, example B has 14r plus 20 is less than 12r, or 14r plus 16. I want you to change that to 12r. We don't want it to be 14r. Okay, so change that to 12r. Didn't want to waste paper. All right. So I'm going to start by saying this. These are two separate equations. We're going to solve them both independently and then graph them on the same graph. So I'm going to split them up. Solve this one for r first and then solve this one for r second. Now to do that, I need to get rid of one of these r's. So I'm going to take away 12r from both sides. I get 2r plus 20 is less than 16. Now remember, this does not affect the sign when you add or subtract, so we don't have to worry about changing the sign. Okay, subtract 20 from both sides to help get that r by itself. So we get 2r is less than -4. Divide both by 2. I get r is less than -2. That's the final answer for that one. Okay, so I can go ahead and plot that. I have my -2 on my graph, and I'm going to put my 0 on my graph. Less than on the -2. Remember, as an open circle, it's not included. I'm going to do my 0 check. 0 less than -2. Is that true? No, 0 is not less than -2, so the arrow is going to go away from 0 to the left. Okay, now we need to check the second one. All right, to get r by itself, I'm going to add 10r to both sides to get rid of one of them. Okay, I always like to get rid of the smallest one because that's going to guarantee that my side's a positive answer. My other side has a positive variable. Okay, so with 8 on this side, I got 15 minus 9r. then subtract. Okay, so I get negative 7 is greater than or equal to, I'm sorry, this is not 9r, this is 1r. Negative 9 plus 10 is 1r. So negative 7 is greater than or equal to 1r. Put that negative 7 on there, but look, negative 7 is already in my solution. So we just need to check to see which way the arrow goes. I'm going to put my closed dot, because it's greater than or equal to, plug in 0. So I get negative 7 is greater than or equal to 0. I need to fix that. Alright, let me fixing that real quick. So negative 9r plus 10 is 1r. And negative 7 greater than or equal to 0. Not true. So it's going to go away from the 0. So this arrow goes this direction as well. So we've got basically one arrowed solution that applies to both of these equations. Right? So anything less than negative 2 will satisfy both of these equations. Alright, pause the video real quick and try A on your own. Okay, what you should have done is solve for x. So in this first one here, I'm going to subtract 1 from both sides. Okay, I'm going to get 5x is less than negative 4 minus 1 is negative 5. Divide both sides by 5. Get x is less than negative 1. Okay, come down here to my graph. Plot negative 1 and 0. Open circle because it's not included. And then check your 0. So 0 less than negative 1. Is 0 less than negative 1? The answer, no. So I don't want my arrow to go towards 0. It's going to go away from 0. Okay, last one, what you should have done, add 2 to both sides to get that x by itself. So we get 6x greater than or equal to 12. Then divide both sides by 6. Okay, so we get x is greater than or equal to 2. And so closed circle, greater than or equal to, goes this way. Check your 0 just to make sure, but 0 greater than or equal to 2, no it is not. So this also wants to go away from the 0. So this is my final solution. Okay, so there's 4 practice problems at the bottom of this note sheet for you guys. Finish those up for tomorrow. Have a great night.